What is up, Algebros? This is Algebra 2, Lesson 2.4, which is talking about sketching graphs of functions. Now, the lesson starts off graphing just linear functions, and kind of the way what we're doing today is taking key features that we know about the graph and then graphing those. And so some of the key features are x-intercepts, y-intercepts, where the function is positive or where it's negative, where it's increasing, going up, where it's decreasing, going down, or end behaviors, which is what we talked about in 2.3. And then it goes on talking about nonlinear functions, which still includes all of these, but then it also adds these. Continuity, where the graph is continuous versus where it's broken up at. Extreme, where it might have a maximum or a minimum. And then maybe symmetry, where it's the same on the left and the right. So I think the easiest way is maybe just to see a few examples of these, so we're going to jump right in. This is guided practice number 1. It says, use the given key features to sketch a linear graph. Since we know it's linear, we know it's going to be a line. So let's see if we can I'm going to go and underline that, linear. It tells me the y-intercept is at -3. So the first part of my graph is going to be right here at -3. On my y-axis, it's crossing at -3. It says the function is positive for x is bigger than 1.5. So since it's positive for x is bigger than 1.5, anything beyond 1.5, it's going to be up here above the graph. So that means it's probably going to have an intercept right there, 1.5, and up above it, it's going to be up there, right? Let's see. It says the function is increasing for all x values, for all values of x. The domain, let's go with a different color. The domain is from -2 to 3. So I can only draw x's from -2 up here to 3. That's all my x is. And then my range is from -7 up to +3. This area for my range. So then let's see if we can draw this. I know it's positive up here. So we're going to have these 2 points. I'm going to see if I can connect those. Kind of going up 3/1.5. So I'm going to go there. Just kind of continue on to that point. So that's what my graph is going to look like for this one. So now let's try a couple non-linear ones. Over here we're going to do A, and over here we're going to do B. So it says the y-intercept is 2. That's easy enough. We'll put a 1 right there on 2. The function is negative for x is less than -1. So when x is -1, if it's smaller than that, it's going to be down here. And for x is bigger than 4. So it's going to be down there. The function has a maximum at 3, 3. 3, 3. This is its maximum. So then I'm just going to take a sketch. I know it's negative down here. Right there's the highest point. And it's going to go down that direction. So there's a sketch of that. Could I have drawn that differently? Yeah, I could have done this. Right? Could have done all different things. Still met that criteria. Y-intercept, maximum, going down there, going down there. But that's just a basic one, is the black one that I drew. All right, here's the next one. It says the function is symmetric about the line x equals 2. So I'm just going to draw this in yellow here. X equals 2 is a vertical line. So I'm just going to try and do a dotted one here on x equals to 2. So it's symmetric. That means on the left and the right of that line, it's going to look exactly the same. The function has a minimum and an x-intercept at x equals to 2. So it has a minimum and an x-intercept at x equals to 2. So this is the lowest point that it gets. And then it says, as my x's get really big, as x approaches infinity, my function approaches infinity. So that means as I move out this way, my function is going to keep getting bigger. Also, as x approaches negative infinity, meaning as x's get really small, my function also gets really big. So since it's symmetric, I don't know exactly what it's going to be, but I know whatever I draw on the right, I have to draw the same thing on the left. So I'm just going to make up some few points, maybe just a point here. I know as I move further right, I need to go up. So maybe this one here and there, and then I don't know, we'll go here and here. So whatever I draw on the right side of this line, I need to also have on the left side of that line. Is there a different way that I could have drawn that? Yes, I could have drawn it a lot of different ways. Like if I would have wanted to do this, I just would have tried to do that same thing over, and I can't do that. But I could have drawn the same thing over there. As long as it's the same left and right, this point here would have to be a minimum, and I have to draw the same in left and right. I hope you basically get the idea. Feel free to watch it again, or watch some more examples there from that your book provides. Your homework is a worksheet, so make sure you pick that up, and good luck, guys.